formed has been the main metal for millennia. But in the mid-1800s, a new material hit the streets: aluminum. Now, aluminum's late start was due to the high current electricity needed to extract it from bauxite ore. No electricity, no aluminum. And as you might imagine, when it first came about, it carried with it an astronomical price tag. Emperor Napoleon often dined off aluminum dinnerware, while his first officers had to make do with a meal of gold. But nowadays, aluminum is still 10 times the price of steel, but it is much more affordable. And people are beginning to wonder if those new Ford F-150 trucks made of material they associate with soda cans can really hold up. Well, today we're going to analyze these two substances in 3 ways in addition to weight. And those ways are strength, durability, and ease of use. So, let's begin. Two things primarily determine the strength of a steel: its carbon content and its temper, which is how hot it's heated and how quickly it is cooled. Low carbon steel is very flexible, such as this paper clip right here. A slightly higher carbon content steel would be like this bobby pin. It flexes right here because of the spring, but this part right here is pretty hard to bend. Not impossible, but you get my drift. Now, as far as tempering goes, this might make it stronger and harder, but at the same time, a high carbon content and temper often make it so hard that it's brittle. And when that happens, well, kind of defeats the whole purpose, doesn't it? So, when you're working with it, you have to take into consideration what exactly are the properties you are looking for. The way a classic blade is made is a prime example of this. Often, everything except for the cutting edge and the tip are coated in a clay paste. Then it is heated to over 800 degrees Celsius, which is bright red. Then you quickly plunge it into the water, which results in a highly tempered edge, which will hold its sharpness in the heat of battle, along with the flexible spine which keeps it from snapping. Which, if your blade snaps, you are not about to have a good day. In fact, it might be your last. Steel is a durable, wear-resistant material, which can be frequently bent out of shape and returned without becoming fatigued, making it ideal for things like springs, as well as items in constant friction with other components, such as the rotor disc in your car. The downside with steel is it tends to rust away when it's left exposed to the elements. There is a way to counter this. It's called stainless steel. You simply add about 13% chromium and its chemical resistance goes way up. However, this lessens other properties. It's harder to cut, not flexible, and is pretty bad at conducting electricity. And on top of that, the price is at least double. So, there's an option, but let's keep on moving. It was very easy to weld, and These wheels are quite strong and quick, and it's great for on-the-job repairs. You can usually fix anything you mess up. However, when working with, you have to keep in mind it's going to eat through your cutting wheels like no tomorrow and dull most of your chores. And if you want to do any casting and forging with it, you're going to need some pretty extreme heat. And on top of all of this, it's very difficult to machine. Now, despite some of the tooling drawbacks, steel is a strong, durable, wear-resistant material. So why would anyone want to use aluminum? Well, the main answer to this question is quite a weighty topic. You see, a cubic foot of steel would weigh about 490 pounds. That's roughly 3 times the weight of aluminum. So,
with that in mind, let's look at aluminum.
As far as strength is concerned, aluminum is, depending on the alloy, between 45 and 75% the strength of mild steel. Which means to make an equally strong part, you have to make it at least 50% thicker. However, at the same time, that part would weigh 50% less. And while most alloys you do not want a carbon content and heat treating / tempering is just, you don't do it. You can alloy aluminum, which is sort of the same thing, not really, but same property changes, and it's a lot more complicated. For example, pure aluminum is relatively soft, it's a good conductor of electricity, and it's food safe. However, throw in a dab of magnesium and you get yourself something that's light. Add a little bit of copper and you get something that is hard. And you add a little bit of zinc and it's just overall strong. So, you can't necessarily call it weak. Sure, it's weaker than most steel is, but when you consider the weight to strength ratio, a lot of times it lands on the side of aluminum. Aluminum is not as wear resistant as steel, but this is generally made for by its thin but strong oxide layer in everyday use. This layer is aluminum oxide, better known as ruby, the second hardest gemstone after diamond, and it can be thickened in a process known as anodizing. Aluminum is actually harder to dent than most steels, but when it does fail, it is often an irreparable crack. And it also becomes fatigued much more rapidly. So, these are all things you need to consider. On the plus side, with the exception of a few alloys which suffer from galvanic corrosion, aluminum can last decades outside without succumbing to the elements. When working with aluminum, one needs only basic hand tools to cut and shape it with ease. It can also be rapidly machined into intricate parts. The only real drawback is when it comes to welding, as it needs special equipment and it is very challenging. Also, if you scratch your part, nothing you can really do about it, unless you could sand it down. So don't make a mistake. So one good thing about this is you can cast it and forge it. amateurs can do this. Pretty simple to make an aluminum foundry, and you can be making your own complex molds and patterns right in your backyard, like I did. In the end, neither can be crowned the best nor easiest to use in all circumstances. You see, blades will always be comprised of steel, and until titanium gets cheaper, your aircrafts are probably going to be aluminum. However, with stronger, lighter alloys of aluminum being developed on a nearly monthly basis, and couple that with a price drop from $12,000 to 72 cents over the past 200 years, expect to see more aluminum in your future. This is Tech Taze, signing out.